This is Aaron, and with me today is Peter Lindemann. And today we're going to be discussing Peter's presentation at the recent Bedini-Lindemann conference that we had in Hayden, Idaho at the end of June. And Peter had two presentations at the conference. One of them that he did on Sunday, the last day of the conference, was Open System Thermodynamics, which is at opensystemthermodynamics.com. And but his first presentation that he did on Friday was actually Battery Rejuvenation, which is kind of a companion presentation to the popular Battery Secrets, which goes into the battery chemistry, how battery really works, what the sulfation process actually is when a battery gets sulfated, and that kind of stuff. And the Battery Rejuvenation presentation that you did actually goes into the methodology of actually nursing dead batteries back to life. So you want to kind of explain a little bit, a little synopsis of...
Yeah, the thing is that everybody's talking about, that batteries get sulfated and that you have to, get rid of the sulfation or something else. And so I really get more into exactly what the chemical state of the sulfation process is. Sulfation in a battery is not bad, but what happens is that if sulfate ions are left in the plates, they change form, so there's actually two chemical forms of the sulfation. And the first form is good, it's a natural process of how the battery is charged and discharged, but the second form is far less mobile, and that's the one that starts causing problems. So I get much deeper into the discussion of what's going on with the sulfate ions, and when they do change to the second form, this is when currents stop moving so well in the battery, and what we have to do to get that second form of sulfation back, to turn back into the first form so that it can be literally brought back into the electrochemical pathway. So that's really what it's about. This material has never been discussed in the public domain before. It's definitely not covered in Battery Secrets, which is just a general primer, really, overview of the chemistry of a battery. And so this presentation goes much deeper into exactly what's going on.
So together with Battery Secrets, and if somebody has never had or seen Battery Secrets, it is at batterysecrets.com. That was a presentation you gave about, I don't know, three years ago?
2010, or yeah, the 2011 conference.
Bedini conference out at the resort in Coeur d'Alene.
Right, exactly.
And so between Battery Secrets and with Battery Rejuvenation, those two pretty much make, that's the most comprehensive and definitive information on truly how to restore a battery, using the Bedini chargers, the SGs, or by whatever process to truly rejuvenate it, not by using additives and pouring different chemicals into the battery, but basically just using water and electricity.
Right.
And the proper tools and equipment to see what you're doing, you can, bring a high percentage of batteries back to life.
Yeah, if it's recoverable.
If it's not internally shorted or physically damaged or warped or whatever.
Correct. In other words, if it's possible to bring it back, then these methods will do it.
Right.
Right.
And there is a good percentage of batteries that a lot of other battery rejuvenation methods can't bring back, and chargers that aren't able to charge them up. And a lot of these batteries that are sitting in the dumps can actually be recovered to maybe 80% to even over 100% of the manufacturer's rating using these processes.
Exactly.
And then we've seen this over and over for years.
Right. Yeah, we've all of these things. None of this is theoretical. All of these things have been done hundreds of times at Bedini's shop. And starting in 2004, when I was working for him, we started tracking charge and discharge cycles with computers and overlaying graphs and other things, and really starting to see what was going on in these processes. And so we really set out to understand the chemistry about what needed to happen, and so all of that is covered in these presentations.
Okay. Now together Peter and I run Tesla Chargers, which is part of our company A&P Electronic Media, where we publish digital products But at Tesla chargers, we get tons of questions that's very relevant to the information and content in both Battery Secrets and Battery Rejuvenation.
Exactly.
And that's going to, between both presentations, is pretty much going to answer almost just about everything that you need to know about rejuvenating batteries in the proper way. And I know, I do a lot of the customer service for Tesla chargers, and one of the most popular questions, even though it's on the website, is can these chargers or these methods be used for lithium batteries, or is it only for lead acids and NiCads, nickel metal hydrides? How do you answer the lithium question? Because usually the answer is no.
Well, we tell people on the website no, it's not for lithium. And the reason for that is that lithium is an explosive metal. When you just take lithium metal and you put it in water, it immediately dissociates the water into hydrogen and a hydroxide ion, creating lithium hydroxide and heat. And quite often that heat is enough to actually ignite the liberated hydrogen. And we've seen in the news over the last year, the fact that the Boeing Dreamliner 787 was grounded for 4 months because of problems of lithium batteries exploding into fire and causing fires on the airplanes. So lithium is a very interesting metal in the presence of water, and as we say in Battery Secrets, basically any battery is just a water fuel cell. It's a reversible chemical water fuel cell. And so when lithium batteries are charged, they're going to, there is a water cycle associated with them. And so these things have to be managed very, very carefully in lithium type batteries. Otherwise, they overheat or try and off-gas. And usually the lithium batteries are a sealed battery, so there's really no place for the hydrogen to go. No place for the heat to get out very much. And so typically what the manufacturers have done, especially with smaller lithium batteries, is that they put a fuse in line with the charger. And so because lithium and NiCad and nickel metal hydride and these types of batteries don't change voltage very much during the charge and discharge cycle. The voltage remains pretty much the same, but the total currents available are what's rising and falling. They're really designed to not be charged by pulses or anything that would look like a current surge or an overvoltage condition. And many of the Tesla chargers have been designed to do that kind of thing, and because that works very well with lead acid batteries. And so typically what we saw early on is that when you apply these methodologies to lithium batteries, it just blows the fuse in the battery and then it refuses to do anything. So it looks like we started being told, you burned out my battery and these are expensive and it's your fault and all. So we just put everything on the website that just says don't use these processes or our chargers on lithium batteries. Now, done carefully, there is nothing wrong with using a Tesla charger on a lithium battery. And the bigger the battery, the easier it is to do that, especially if you're using the 1AU, for instance, which has a voltage range that you can dial up. As long as you stay on the low end of the dial, you might get away with charging some lithium batteries. The problem is that if you blow the fuse, we can't help you with that, and so we don't want to be responsible for that, and we don't want to hurt your batteries. But that's really the issue. It's not that our chargers won't charge that chemistry, they charge it just fine, but there are these other issues, including heat, off-gassing, and fuses, internal fuses, which is why we say don't use our chargers on lithium.
So if you do use these chargers or these methods, or if you've built your own Bedini-SG, whether you're charging with the spikes or with the cap dump or whatever, completely at your own risk.
Right.
Some people have brought them back, but for the most part, we don't recommend it. So,
and for these issues. And of course, if you go into the battery and you do a little bit of surgery on it and you bypass the fuse, you see, then if your house burns down, a year later, and they find this thing, in the fire, the insurance company will just say, well, you modified this, and therefore your insurance doesn't cover it. So, and we don't want to be responsible for anything like that either, and that's the reason why, we just say at your own risk, or just don't do it.
right. Now for, voltages, a lot of the questions that I get, that's, very specific to charging batteries up to the proper voltages, or even draining a battery down. A lot of people really don't know what the difference is between a starter battery, which is like a 12 volt battery in your car, at X amount, couple hundred cold cranking amps or whatever, and then comparing it to the same 12 volt deep cycle battery, which is not rated in cold cranking amps, it's rated in amp hours.
Right.
And if you notice on your starter batteries, they're not rated in amp hours.
Right.
And so when treating a battery good, you only want to bring it down to its safe level. So do you want to go into the discharge voltages for both a starter battery and a deep cycle battery?
Sure.
12 volt, for example?
Sure. Let's just go over the difference between a start battery and what we'll call a run battery, like what you'd see in a golf cart or something, or some other electric device that's just designed to run on the battery. Typically, a start battery has a lot of thin plates. In other words, what the chemistry and the physical makeup of the battery is designed to do is to provide you with 1,000 amps to run your starter motor for a couple of seconds. Okay, and that's its main job that it has to do. So it has to have a lot of surface area, and it doesn't have to run very long to do that. So a start battery usually has a lot of thin plates in it, whereas a run battery has a lot fewer plates, but they're much thicker, because what you don't need as high currents, but you want those currents to be available for a long time. So that's the general difference in the construction of what's called a deep cycle battery or a start battery. But typically, you really don't want to try and discharge a 12 volt, what's nominally called a 12 volt battery, down below, say, 10.5 volts.
For a deep cycle?
For a deep cycle, or even for a start battery. That, if you've gotten it down to 10.5 volts under load, okay, what that will do is, once you take the load off, it will usually bounce right up to around 12 volts again, after the load's been taken off. And a 12 volt battery standing at 12 volts is about 95% done. Okay, in other words, there's almost no power left in it at all at that stage. And so anything beyond that, you're just trying to get the last 3 or 4% out of it. There's almost nothing left. Typically a 12 volt battery, whether it's a deep cycle or a start battery, will stand fully charged at about 12.6. And so basically in lead acid batteries, you're really just operating between 12.6 and 12.0. That's the voltage range that has not over 90% of the power in it. And you can, under load, of course, you're going to see that voltage sag a little bit below those numbers, but that's the general standing range for the voltages.
Right. So when you charge a battery up enough, when it's fully charged and it comes down and rests at 12.6, that's fully charged.
That's fully charged.
Right.
You should consider a battery standing. If you just walk up to it, stick a voltmeter on it, and it says 12.6, there's a good chance that it's fully charged. It could also be, if you don't know the history of the battery, it could also have been fully charged, a year ago and still be showing 12.6, even though there's a very thick layer of sulfation on the plates, and you wouldn't be able to get any currents out of it because of that, and it would still show the general surface charge of 12.6. So voltages alone in a battery don't tell the whole story, but it's a good first indicator.
It's easy to get tricked by it.
You can be tricked by it.
Yeah, you can put a load on it, and that 12.6 will it might just drop out to 10 volts or something.
It may drop out to 3 volts.
Yeah.
I mean, depending on the thing. So,
right.
Yeah, it's a good first indicator, and if you know the battery is operating well, in other words, can deliver currents and take good currents during charging, then the voltage can be a very reliable indicator of the state of charge.
Okay. Now with charging batteries to begin with, a lot of the stuff out in the media and in the scientific world is always talking about all these new types of batteries and all this, and it almost makes lead acid batteries look like dinosaur technology, when in fact it's almost a perfect battery if it's just charged and discharged properly.
Absolutely.
Because utilizing these methods, if it's discharged to a voltage that's safe and then charged up to a high enough voltage to truly desulfate it, then theoretically you can have an infinite number of charge and discharge cycles on a lead acid battery.
Yeah.
Okay.
The chemistry is 100% reversible. Which basically means that there is theoretically no limit to how many times you can run the chemistry this way and then run it back. Okay. Of course, there's real world limitations, but 5,000 cycles is quite often indicated by manufacturers of deep cycle batteries. They should run 5,000 cycles, even though, like in solar homes and golf carts and things like this, people are very lucky to get 600 or 700 cycles out of them. But the manufacturer will stand there and say, this was good for 5,000 cycles. And with our systems, you can easily get 5,000 cycles out of them, and sometimes even more.
Right.
The reason we have focused, or the Tesla Chargers focuses primarily on lead acid batteries, is that there are more lead acid batteries on the planet right now than there are human beings, and we're over 7 billion human beings on the planet, and there are just a staggering number of lead acid batteries, and it's the most used battery. There's still far more lead acid batteries made on a daily basis than any other chemistry, and the flooded cell versions, in other words the ones where you can add water to them, are the most forgiving and the easiest to overcome internal damage than any other sealed battery construction methodology. So that's why we have focused primarily our chargers on charging and rejuvenating lead acid batteries, because they're the most common.
So with charging the lead acid batteries, or even the NiCads, nickel metal hydride, typical rechargeable batteries, tool batteries, little AAAs, all the way up to the square 9-volt radio batteries. Right. Now let's just say like a 12-volt lead acid battery, sealed or flooded. What's the typical voltage that, if you just went to Walmart or some car store and you bought a battery charger and you hooked it on there, what's the typical voltage it will push at 12 volt like a starter battery to?
Typically they are limited to somewhere in the 14 volt range, somewhere between 14.2 and 14.6. I doubt if you would find anything off the shelf that would push it higher than that. So that's the answer. Okay,
so in a lower 14 volt range, and which kind of goes into pretty much the primary reason why the batteries degrade after each charge and discharge cycle.
Exactly.
Because that voltage isn't pushing the battery high enough in each cell to desulfate and reverse that chemistry.
Right. And when he says desulfate here, what we're really talking about is just chemically reconverting the sulfate ions that have been laid onto the plates during the last discharge cycle. What we want to do is we want to chemically recombine those with hydrogen during the next charge cycle to take all of those sulfate ions and put them back in the electrolyte In other words, get them off the plates and put them back in the electrolyte where they started at the beginning of the charge. So what we talk about is voltages above that 14.5, 14.6 range, anything between there and say 15.5, is what we would call a finishing charge, something that is going to go in and get all of the rest of those remaining sulfate ions out of the plates. And typically that's going to be in the range of 0.5% to 0.25% of the total number of sulfate ions in the battery are going to be captured during that last part of that charge, but they won't be reclaimed in the system if the voltage of the battery is not allowed to rise to those higher levels. You can sit there and boil the battery for 12 days at 14.5 and you'll never get the sulfate ions that you could get within a half an hour if you just pushed it to 15.5. And that's something that the battery manufacturers know. And in other words, if you buy a battery and you just use a standard charger on it, and you charge it to 14.5 every time, by God, the first 100 times you do that, man, that battery is full, it seems great, but you've left this very small amount of sulfation on the plates at the end of each one of those charges. And that's what starts building up. That's the problem. And the longer that sulfate stays in the plates, then it starts converting to that second form that I talk about, and that's what starts blocking the currents.
Right. So, so it's kind of rigged for the battery to fail, and obviously they're in the business of selling batteries. So, over enough charge and discharge cycles at those lower charge voltages, you're going to have to buy a new battery after X amount of years. And
exactly, and that's really the difference between when you go into the auto parts store and you buy a battery that's rated for 24 months or 36 months or 48 months. They know pretty much when that battery is going to fail when it's put into the kind of service that it's designed for, because they know exactly how long it's going to take for that sulfate to build up in the system and start making the battery not function properly. And it's usually within 1 or 2 days after the warranty's out. So they've got this timed out pretty well, but the battery can last a lot longer than that if it's periodically put into what we call a topping charge, and those other sulfate ions in the plates can be resolved electrochemically.
So with rejuvenating the batteries in your battery rejuvenation talk, you also go into selecting the right battery to even spend your time on.
Right.
Because there's a lot of batteries that within a couple minutes you can tell that it's not even worth messing with.
Exactly.
And you don't want to spend your time dealing with batteries that are shorted inside, or if they're warped and the case is bulging and this and that.
Right.
Doesn't matter what method you're going to use. Some batteries you're just not going to be able to bring back no matter what.
And also, there's also batteries that you could bring back, but it might take you a week. And as an exercise in education, certainly John and I spent, sometimes we spent a couple of months trying to figure out how to bring certain types of batteries back, and just to learn, what's going on. It depends on what your goal is, really. If the battery rejuvenation talk is really about how to orient people not only to the process, in other words the technology, but also the art, the way of using the equipment properly, and then also the method to determine which batteries are are going to be the bread and butter of this if you want to do it as a business. Because there are kind of a couple of very cute tricks which I teach in the film, which allow you to determine which batteries are worth your time, because time is money in a business, worth your time to rejuvenate.
The low-hanging fruit.
The low-hanging fruit. This is the how to scrape the cream off the milk if they're.
Right.
For those of you who are under 30, you probably have never seen cream sitting on milk. But for us old timers, used to used to show up every day in the milk chute in the wall.
You know, and those batteries that are the prime candidates for rejuvenation, I mean, there's plenty of them at golf courses, or companies that lease, you know, golf carts. I mean, the issue of changing out batteries is so big. A lot of golf courses don't even own golf carts anymore.
Right.
They go to companies that lease them out because they deal with all the battery
Correct.
changing and stuff. But even at the scrap yards, you know, we have a place here in Spokane called Earthworks. You can go there, and there's always people bringing in batteries,
Right.
and there's a percentage of them that, you know, a few charge-discharge cycles is brought back like new.
Right.
So it's just a matter of spending a few minutes just to find out which ones those are, and the battery rejuvenation presentation goes into all those details of exactly what you need to know.
Right. But not only those places, but you know, any of the auto parts stores, because they're buying batteries. People bring in their batteries and they stick them on the tester, and the thing says, buy a new battery. Because really they're only looking at the raw impedance of it. In other words, will it develop any current or not? And many batteries that have just been sitting around won't anymore, but that's a perfect candidate for rejuvenation. So a lot of times you can just go in and just take 10 batteries from the back store area of an auto parts store, and you might be able to bring 5 to 8 of those back into service as well.
Right.
So it just depends on what you're looking for.
And so, like, getting back to the voltages, for example, certainly the chargers that Bedini makes that we have at teslachargers.com brings the batteries back to the proper voltages, and that's, whether it's solar or the chargers that you actually plug into the wall. And something that people can experiment with just to prove the point about getting a battery to the right voltage to charge it up. Could it be as simple as somebody taking a Variac, putting a full bridge on there, and they got 120 cycles a second pulse DC, and then just start down low, put it on the battery, and just slowly turn it up until that battery voltage gets to like 15.3, 15.4.
Sure.
That
works all the time, and you can also use just industrial grade power supplies and things like that, where you can just dial up the voltage and be very careful about how high you push it. So in that sense, the chargers we sell aren't the only way to do this. In other words, there isn't any magic in pulsing or not pulsing, or negative currents or radiant energy, or none of that is really the magic button in all of this. And I go through that in Battery Rejuvenation Talk, that we learned these things by investigating all those methodologies, but in the end, those weren't the important things that were the real takeaway from this process. And if you allow the battery to determine its upper voltage during the charge, then it will rise to as high as it can. And I talk about that. And as long as you don't artificially limit the upper voltage with the charger itself, then you have the possibility of doing a topping charge. Then the other considerations are you doing it carefully enough so that you don't produce a lot of heating and off-gassing of hydrogen and oxygen at the end of the charge? And those are basically the things that need to be managed simultaneously, and that's what our chargers do automatically for you. So, if you don't want to learn all of this stuff, then our chargers are very, very handy, because they just do it. They're hardwired to do that. But if you're really interested in doing this as a hobby, or as a small home business, just learning about it, you can easily build devices that will show you that there's a wide variety of ways of getting a battery to finish its chemistry.
Mm-hmm. And the longest running project that that is around where people are making their own battery rejuvenator is actually the Bedini SG.
Right.
You know, and at Bedini-SG.com you can get the exact specs that John uses, and these SGs have successfully rejuvenated, you know, probably tens of thousands of batteries over the years.
Oh, yeah.
You know, keeping countless tons of batteries out of the dump.
Yeah.
You know, and Bedini-SG.com / intermediate, you can get all the capacitive discharge concepts down with the SG to be able to rejuvenate batteries by discharging a capacitor into it.
Mm-hmm.
And again, you know, like we just mentioned, if you do want to try it on your own, you can rectify the output of a variac and just slowly, you know, put that pulse DC to a battery, and then on it like a 12-volt battery, slowly turn it up, and so what, 15.3, 15.4, that's about.
Well, what I would do is,
Ranger.
here's the thing, is that, you know, if you're going to do these other methods, first of all, I wouldn't put a variac and a rectified variac on a battery without having a voltmeter, an external voltmeter on there as well, because we want to know what's going on. And I would also try and monitor the temperature of the battery to make sure that you're not charging it too fast, because if you do, then it's going to start heating up. And then I would also observe how much off-gassing there is, how many bubbles are coming up in the cells, and you want to keep that at a minimum. And but then in the end, you want to just you know, recognize when the voltage, you know, is rising, and at a certain point it's just going to stop rising, okay? And we don't know where that's going to be, and that depends on the condition of the battery. In other words, if there's a whole lot of sulfation in the plates that has yet to be resolved by you know, the proper methodology, that battery may absolutely top out at 15.0, you know, 15.0, and you couldn't raise it higher no matter what, but at least that's higher than 14.5, okay? But by the time you get all of the sulfate ions out of the plates and everything, that battery may be able to top at 15.8, okay? And so where it tops and you know, what's its temperature, are all the cells the same temperature, all these kinds of things. These are all indicators as to whether or not you know, the health of the battery. And you just learn to interpret all of these indicators. And I talk about kind of learning battery talk, because the assumption is that the battery is always telling you the truth about its condition. So we just have to learn how to interpret the signals that it's giving us.
Now, a great tool that you might want to consider getting if you really want to, you know, do this in any serious way to really see what the battery is doing, and a lot of times you'll see Bedini post different battery charts of the charge and discharge. There's a company called West Mountain Radio, and they have a computer battery analyzer, CBA4, I believe is the latest model, and you basically plug it into your USB port on a computer, and then you take these two leads and you hook it to the battery, and it monitors the voltage. So as you're charging with the TeslaChargers.com chargers, or whether you're doing any of these other methods, you can see over a period of time exactly what that charging graph will look like, so you can know, you know, when it starts to come up to a plateau and stuff. But not only can you monitor the charge, it's equally important to make sure you're doing discharges on the battery too, because some batteries you're going to need to charge it up, but you're also going to need to discharge it, then recharge it, discharge, charge, and over multiple cycles you'll see that the capacity is increasing little by little until you do a couple cycles and the capacity is pretty much the same. Then you know that battery is as good as it's going to get for its condition.
Right.
And that computer battery analyzer from West Mountain Radio, it also has a discharge capability where you can type in what your C rating is, you know, like a C20 discharge rate, and it will actually apply a certain fixed load to it to draw a very specific amperage for whatever voltage there is over a period of time, so you can see the battery come down until it hits, you know, 10.5 or whatever the lowest voltage that you want. And each charge and discharge cycle, you can see that it takes longer and longer to hit that bottom voltage, which means your capacity is growing.
Ideally, okay.
Ideally. So,
He's telling you what happens, when the battery's actually been
right.
being treated right and it's actually healing and responding well. Of course, everything he just said could turn out to be a complete lie in regards to other batteries, where every cycle you do this process on, it gets worse and worse and worse until it just doesn't do anything at all. And there's reasons for that too, and I talk about why some batteries may respond, differently. And so that's why you really want to understand the full process and how to do it right, so that you aren't hurting the battery. So do we have any questions from the, what do we got here?
Okay, let's see, start up at the top here. Okay, what I'm going to do is there's a handful of people who, let's see, if you want to ask questions, you can either do the little hand-raising deal to ask a question, or you can type your question into the question section.
Can we just look through the questions there and just see if...
Yeah, I'm seeing if anybody has their hand raised.
Okay.
If we can take
an audio question. Yeah.
Okay, so nobody has their hand raised. Are there any... Okay, so here's a few questions here. Let me see if I can open that up here. Okay. This is from... Okay, Shamitha Gopal. She's already left, but we'll ask it anyway. Can a layman woman rejuvenate batteries as a business?
I think so. I think one, you're going to have to decide what kind of batteries you want to operate on. Obviously, golf cart batteries, which weigh 70 or 80 pounds apiece, might be a bit much to lug around. I know I don't like to lift a whole lot of them myself. But tool batteries, the old nickel cadmium batteries from like DeWalt and Makita and some of these older models, which where the tools were very, very good and the batteries are now very expensive to replace. There can be a very lucrative battery rejuvenation business in that range, with batteries that you can easily hold in your hand. The first thing you need to do is decide what kind of batteries you're wanting to, what kind of service you're going to try and provide, and then just figure out how you can source a whole bunch of these, so that you can go through and do the numbers, and because if you can rejuvenate 75% of them and just recycle the rest, then it can be quite lucrative. And yes, a woman can do this business.
Yeah, for sure.
Absolutely.
Yeah, and there's a lot of women who buy the Tesla chargers. I don't know if they're actually doing it as a business, but we have a lot of women who are customers around the world, because they see the value of this, and there's quite a few women who also build SGs, to study it, and I don't know any women who are actually doing it as a business, but yeah, it's not limited to anybody.
Right.
I mean, it's very simple and straightforward, really.
Right.
Okay, this is a question from Wayne Jackson.
Hey, Wayne.
Peter said to discharge batteries to 20 volts on the third discharge cycle. Is this under load or no load? I am using 4 golf cart batteries. I'm discharging at 18 amps. Disconnected load at 20 volts and instantly got a reading of 21.6. Discharged at 7 amps down to 19.5 volts, and within 12 seconds of removing load went to 20.7.
So here's the thing. 6 golf cart batteries are going to have a nominal voltage of 24 volts. Just so we kind of bring everybody up to speed here.
6-volt batteries.
6-volt batteries. These are he's talking about charging and discharging 4 golf cart or 6-volt deep cycle batteries that are, I'm assuming, are connected in series. Okay. Now, for the most part, we don't have 24-volt chargers. Most of our chargers are 12 volts, and the 1AU can handle up to 24 volts, but only at 1 ampere. So, but 20 volts for a 24 volt system is really pretty dead. That's way below where you would expect standing voltage to be for 4 6-volt batteries in series. So there may be some dead cells in those batteries, and again, this is one of the reasons why we like to keep the series strings as short as possible. 12 volts is typically for the most part for rejuvenation as high as we really want to go when we're rejuvenating. Just because if you have 6 battery cells in series connection to get up to 12 volts, any one of those cells could be bad and not generating its 2 volt contribution to the total 12. And the more you have in a string, then it only takes one to wreck the string. You see, so we want to try and rejuvenate batteries in the shortest possible strings, and that's why we generally do it at 12 volt levels. So I'm going to kind of sidestep your question here, Wayne, because 20 volt standing voltage either tells me that these batteries are really overly discharged, or there may be even some shorted cells or some bad cells in those strings, and a different procedure would have to be applied to these to find out where the problems are. The problems could all be in one battery in that string, and you could have 3 good 6-volt batteries in that string and one really bad one, and get the. So we would need to find out more information to really answer your question.
Okay.
What do you got?
Okay. This is from Cohen Enright. Is off-gas an issue at the higher voltages, or are they pulsed or short charge times?
Okay. Off-gassing always happens at the end of a charge, at least to some small degree. You want to minimize off-gassing, and you don't need to see any off-gassing during the bulk of the charge. In other words, when the voltage is rising up, which we call the charge plateau, which is actually not a flat line, but a slightly curved line, or slightly tilted rising line, you shouldn't see any off-gassing during that period, if the energy you're putting into the battery is actually getting into the chemistry. Off-gassing during the main bulk of the charge means that you're applying the energy faster than the battery's chemistry can absorb it, and that means you're trying to push the battery too fast. So the idea would be to back it off, or to recognize that the battery charger that you have used is too strong or too big, and the battery is too small, or some variation of that. So, but when the chemistry is finishing, way up at the top, there's always going to be a little bit of off-gassing. And you just want to make sure that the bubbles are really small and the total volume of gas produced is very low, and that the temperature of the battery has really not risen much above the ambient. And under those circumstances, off-gassing is really, it's normal in small amounts at the end of the charge. So that's the only place where you want to see any off-gassing.
And it looks like champagne fizz.
Looks like champagne, exactly.
Yeah.
If it doesn't look like champagne, if it's big fat bubbles that are really boiling out the cell, then you're just applying energy to the cell much faster than the chemistry can absorb it, and turn it into that process whereby the lead oxide is being replated on the positive, and the sulfation is going back into the electrolyte. So thanks for that question.
Okay. Okay, this is from Steve Stucker. How does the alum differ in performance and longevity? Can this conversion be done after, say, 1 year of use? So he's referring to the alum
Right.
electrolyte mix.
Okay. So what is, for those of you who haven't followed John and Chuck's work on the alum conversions, I've seen John just take a good flooded cell, lead acid battery. It's working well. Just take it outside, put it in a bucket, turn it over, dump all the acid out. Then just go in, take a couple of ounces of alum, which is the type of alum that is used in baking, which is ammonium aluminum sulfate. Okay, and put that into some warm water, about a gallon of warm water. Shake it up until it dissolves. Pour that into the battery, stick it right back on the charger, and work great. There's a number of places on the internet, and I've seen Chuck say this at the conference, that what they try and do is, he says he's used up to 2 cups per gallon of water of the alum mixture. And I think what he's trying to do is he's just trying to make sure that the water is really saturated with the alum ions, okay? But I've seen it work with as little as 2 or 3 ounces, and it worked very well. The problem with the alum is that alum in water has a very, very narrow solution temperature, and at 70 degrees, it's fantastic. Okay, it will at 70 to 100 degrees Fahrenheit, it will outperform sulfuric acid as an electrolyte in a battery. And what's nice about it is if it spills, it doesn't really hurt anything. It doesn't, you know, if it bubbles up and gets on your clothes, it's not going to bore holes in your cotton shirt and things like that. However, up here in, you know, we're within 100 miles of the Canadian border, so we're pretty far north here in the Spokane area, and the winters get cold here. And if you take an alum battery and you let the temperature of that battery drop to 40 degrees, 30 degrees, 20 degrees Fahrenheit, what happens is that the alum stops being dissolved and literally just starts dropping out into the bottom of the battery as the in the crystalline form again. And at that point, the battery gets very weak. And since our charging methods don't do anything to warm the battery up, it can be problematic. So I don't recommend that people do an alum conversion for their automobile start battery unless they live in Hawaii or southern Florida or, you know, San Diego, you know, or Mexico or somewhere in the tropics, where you're just never going to have temperatures below 65 degrees Fahrenheit. Under those circumstances, it's definitely worth doing, and it gives you a safer battery to work with. But in areas where the possibility of having the battery cool off at night below those temperatures, I think it creates a different set of problems that the sulfuric acid battery doesn't have. Okay. So that's, yeah.
Okay, and if you do want to learn more about what this alum electrolyte is about that John and Chuck have been working on over the last few years, you can go to energiescienceforum.com, and there's quite a bit in there with the experiments in there of different variations of these alum batteries.
Yeah.
Alum electrolytes, or even, you know, alum crystal batteries, and all kinds of stuff in there. So just check out energiescienceforum.com, and you'll find just about everything you want to know about John and Chuck's work on the alum batteries.
Yeah, so there's been a tremendous amount of work done in the last couple of years on this, and it's well worth learning about. and the battery will convert instantly. I mean, John, when I've seen John just pour the acid out, he doesn't even rinse it out, because the ammonium aluminum sulfate has sulfate ions as part of the chemistry in the system too, just as the sulfuric acid does. And so the way the battery works is almost identical from a chemical point of view, and it just uses a slightly different mix of catalytic ions that interact with the battery in a slightly different way, but it's very simple to convert.
Okay.
That's a great question. So where are we now?
Okay, this question has already been answered, but for Ross Bearable, asking about the topping charge on a 12-volt battery, Peter did go over that. If you missed that, I am filming this interview, and so sometime tonight or tomorrow I'll be putting out the YouTube link, and so you'll be able to rewatch this interview on YouTube. So stay tuned for the YouTube link on that. Yeah. Okay, let's see. Okay, this is from Joe Knapp.
Yeah.
Can you post a chart of the difference in C ratings?
The C rating is really you know, typically what the C rating is for a run battery or a deep cycle battery, and they're rated in amp hours, and so the C20 rate, by the way, so in other words, if a golf cart battery is rated at 225 amp hours, okay, at 6 volts, that's the rating of the battery when you buy it, and that number, that 225 amp hours, is the C20 rating for that discharge. In other words, if I discharge that battery at say 11 volts or 11 amps, okay, it can do that for 20 hours, okay, and that gives me about the 225 amp hours, okay. But if I discharge that at 20 amps, I'm not going to get even 10 hours, which would be the, you know, because it can't produce 20 amps. So at 20 at the C10 rate, the rating may only be about 200 amp hours.
Yeah, it's not linear.
It's not linear at all. And if I put it in a golf cart, which I know is going to draw 50 amps when I'm flooring it and trying to get somewhere, yeah, it's gonna you know, be done in less than 4 hours. You've got about 3.5 hours worth of operating time, because that's under the C5 rate of discharge. And so most batteries, if you can find that type of chart on the internet, Joe. But yeah, the C20 rate is typically what is listed on the battery, and it's the most optimistic. But but if, for instance, if I take that battery and only discharge it for 1 amp continuous, it may run for 300 hours. It may give me way more than the 225. And again, so they're typically a deep cycle battery. The listing on the label is the C20 rate.
Right, so you take that amp hour rating on a deep cycle, divide it by 20, and that's how many amps you want to draw, and for 20 hours, it'll give you that rating.
It should. If it's in good shape, that's what it should do.
And on your charge and discharge cycles, like for example, I mentioned the West Mountain Radio Computer Battery Analyzer, you can punch in what C20 rate you want, and if you ask for its recommended, it'll give you a recommended discharge for a particular amp hour rating on a battery, and it will automatically suggest the C20 rate automatically.
Yeah.
And if it doesn't, you can punch it in there, because on the charge-discharge cycles, you charge it up, you want to discharge using that C20 rate as close as you can get for that battery, down before you charge it back up,
Right.
and use that C20 rate, and that's ideal.
Yeah, and especially for rejuvenation, because what you really want to do is you want to work the chemistry slowly but deeply, and especially on the recharge, you want to charge slowly to get a very, very fine deposition, electrode deposition on the plates, which will help build surface area, and that gives you current carrying capacity. So all of these reasons, the rejuvenation process is really about doing things slowly and within spec. Yeah. So thanks, Joe.
Okay. Let's see. Okay. Ian Rowe, he mentioned about, or he's asking about the possibility of charging notebook batteries. We have early on in this interview we talked about the
Lithium.
Peter went over the lithium batteries. And again, I'll post a link to YouTube once I get this video processed and uploaded to YouTube, so you can rewatch that. And Peter did go over the lithium battery topic.
Right, because lithium, most of these notebooks or computers have lithium batteries for weight reasons, and size and weight reasons. And so there are specific things that need to be managed.
Okay, this is from Abdur Atbi. Are there special considerations for AGM, absorbed glass mat batteries, as far as the desulfation goes?
Absolutely. Thanks for bringing this up. Again, the AGM batteries are usually a sealed battery. And anytime you have a sealed battery, there's a couple things. The AGM batteries is like a big, a gel cell type of thing. So in some ways, there's more intimate contact between the electrolyte and the plates than in a flooded cell. But they are very intolerant to off-gassing because they're sealed. So quite often, you just have to be really careful when you're approaching the upper voltages. You really want to back off and do it slowly. That's the real issue. You want to minimize off-gassing as much as possible.
Okay, this is a question from Chris Patton. Have you noticed any wild variables when you apply this method to solar batteries in the 48-volt range, or is that even possible?
Well, it's possible, and like I said earlier, Chris, what we're trying to do is, for rejuvenation processes, we're trying to do this in the shortest possible string. So a 48-volt setup is, if it's in a lead-acid configuration, that's 24 2-volt cells in series, and any one of those could be giving you problems. That's like getting into like a forklift type of battery. And typically what we found in rejuvenating forklift batteries was that we would put it on what we call a hot charger, something that's just going to force current at it. And after a few minutes, what we do is we go around with a thermal indicator and just find out which cells are hot. And those are the ones that are the problems. Those are the ones that are acting more like a resistor than the rest of them. And then we would go in and just try and charge that cell at 2 volts all by itself, instead of trying to force the energy through all the batteries that are good and try and get it into the one that's bad. We would just use a quick method to identify which ones are bad, and then just work on those individually, especially in a string that long. Good question.
Okay, this is a question from Jeremy Russ. How far down should you discharge nickel metal hydride batteries before recharging them?
The nickel metal hydrides are similar to the nickel cadmiums, and you can take those down pretty good. The thing is that those batteries don't change voltage much because they have a potassium hydroxide electrolyte, and only the hydroxide ions are really interacting in the process, but the potassium is not. And so what's happening is in an alkaline battery of that type, the battery uses water to make the electricity, whereas in a lead acid battery, it makes water when it makes electricity. So they run kind of in the opposite direction. So you know, you need to be careful, and especially when you're charging, you don't want to put very higher voltages on these things. You just want to keep, pushing the battery up just a little bit, so that it keeps taking current until it just stops. But be very careful, because you can dry them out, and yeah, there's a different process for those types of batteries, but it can be done.
Okay. This is a question from Dana Moss. Dana from Hawaii. Model number again, please, of the monitoring tool. Let me just type in. I'm going to type this into the chat so you can all see this. West Mountain Radio Computerized Battery Analyzer, which is CBA 4 model, I believe.
Yes, yeah.
Yeah, if you,
IV, right.
Yeah, so if you search that online, you should be able to
bring
find
it right up.
Yep.
Right, and that's a completely software-driven battery discharging system, as well as computer tracking. It's very, very nice. It has very, very robust software package. You can, just on your computer, you can say, I want to discharge this battery at 1.245 amps for 5 hours and then stop, or I want to bring it down to 10.38 volts and then stop. I mean, it has almost an infinite variability in it. And you can say that I want to put, the equivalent of a 2 ohm load on it, or that I want it to continue to take 2 amps out of it all the time. Even as the voltage drops, it'll continue to take 2 amps out of it, whereas if you tell it you want to put a 2 ohm load on it, as the voltage drops, the load will actually drop, because the voltage across 2 ohms is changing. So you can be constant current or constant load. You can do all kinds of things, and then you can also just leave it connected to the battery after it shuts off its discharging processes, put a charger on it, and then graph the charge. And you can just change the color every charge and discharge process, so you can lay 5 or 6 or 10 graphs right on the same graph in different colors, so you can see how the battery is responding. It's really the tool to have.
Okay, this is a question from Tad Mooney. Hi, Tad. Let's see. Automotive alternators naturally put out pulse DC using internal full wave rectifiers in the 14 to 16 volt DC range. Are you aware of any cars on which the voltage regulator is set properly to top the charge up?
Absolutely not. In fact, all of them are specific. And here's the reason why, Thad. Because if the alternator is charging with what we'll call constant current, okay? Even though there's a little bit of a ripple in it, the 3-phase rectified current doesn't have a lot of ripple in it. And so if they, were putting 15.5 or 16, I've never seen one set at 16, by the way, it would put way too many amps on it, in the 12 and 13 range. It would really put, hundreds of amps on the battery, which is not good for it. In that range, so most of them really have voltage maximums in the mid 14s, yeah, I don't know any automotive manufacturer that does anything other than what all the others do.
Okay, this is from Keith Lovelock. What can I do with all my now useless 10-year-old portable power tools?
Well, this is exactly the point. Most of those 10-year-old tools aren't lithium. They're going to be nickel metal hydride or nickel cadmium. And those batteries are quite possibly rejuvenatable. It just depends. If the battery was not just left on the charger continuously, typically what happens is that people leave the tool just plugged in, and leave the charger on as kind of a continuous supply, and that will dry the battery out. At that point, the electrolyte is dead, and those batteries cannot be rejuvenated. However, if you're like a lot of people, you bought really good tools and you use them very infrequently, and what you found is that you charge it up and then use it and then put it away, and it would sit, and that type of situation, you should be able to rejuvenate pretty well. The 1AU is very good for that, but also you can use power supplies and other things. But the process is a combination of charging and discharging, and understanding what the condition of the battery is. And again, I go through all of those things in battery rejuvenation.
Okay. This is from James Gray in Idaho. I have several Absolite AGM cell tower batteries that I want to flood and convert to flooded lead acid and use off-grid with a 12-pole Bedini run with two 68-watt panels charging 2 to 4 golf cart batteries with a Tesla Solar Tracker 3. I've converted the Absolites into 6 to 12 volt units. Do you think this will work for off the grid, or do you have a better idea? I think these bats have been sulfating.
Okay. The first thing I would do here, James, is slow down and take a deep breath. You've got some big ideas here, but you're going to have to break these things down into doable steps, stop mixing apples and oranges and all of these things. Whether or not these batteries are rejuvenatable, whether or not they can be brought back into service, basically has nothing whatever to do necessarily with how you plan on running your off-grid system, whether it's with solar trackers or other 12-pole Bedini machines. By the way, a 12-pole Bedini machine, even though John has demonstrated self-running methodologies, these things should not be generally considered to be fuelless power supplies. Nobody out there is running their house on one of these things that I know of, and you shouldn't be thinking along those lines right now. If these are very, very large batteries, two 60-watt solar panels isn't going to be enough to drive a fly up the wall for this. And again, you've got to be realistic about how much power you're going to get from your sources, and how long it's going to take on an average, cloudy day here in Idaho to charge up the batteries for the size. So you need to scale the system properly as far as how many solar panels there are and how many batteries there are and what your energy needs are. All of those things have to be proportional, and none of that has to do with whether or not those batteries can be rejuvenated. So you gotta break this down into working steps here instead of lumping it all together.
Okay. From Ken Alico, how do you bring a dead battery cell back to life?
Well, again, if they're in a short string, like a 6-volt battery or a 12-volt battery, that cell may be able to come back just by working on the whole battery. If it's a fairly large cell, and it's let's say it's just shorted out, okay. The method to bring it back would be to pour everything out of the battery. You could or just pour all of the electrolyte from that one cell out of the battery, and see if you can't, with a light pressure washer or something like that, agitate some of the sediments on the bottom, which are usually causing the shorts, to move out of the way and come out of the cell. Then take all of that original material that you poured out, not the stuff that you slurried out with the pressure washer. And pour that through a coffee filter or something, get the big chunks out, and then pour all that back into the cell. Never put new acid in the cell. And then see if it doesn't start charging properly and stop acting shorted. So in other words, there are ways, but like I say in the thing, the first thing you do is you get into your rubber suit. You put on your goggles and stuff. When you start pouring acid and splashing stuff around, it's a big mess. And it can be done, but it's a problem. It's a big bunch of mess. And typically, unless you have a lot more time than money, or a lot more money than sense, then these are the things that you end up looking at. So you just have to determine what's worth your time or money.
Okay, this is from Joe Knapp. Should you expect to see the knee event from a battery that needs to be rejuvenated, or only in a properly functioning battery?
The knee should always be there.
And if you want to describe what the knee is.
Yeah, there's on a charge plateau of a battery, it'll rise up, and then at a certain point, the voltages will start rising a lot faster. And you may have seen some of these graphs. I've published them over and over. They're in Battery Secrets. They're in the Bedini manuals. They're in this talk too, Battery Rejuvenation. So the knee should always be there. But where the battery voltage tops out is always going to be different depending on whether 100% of the sulfate ions are available to be brought back into the electrolyte, or whether some of them are still trapped in the plates because they're in this other form that I talk about. So, we're coming up on a 1:15 here, so.
You want to keep one?
Yeah, I mean, yeah. I think people they've still got questions here.
Okay, thanks. Okay, from Michael Swanson, thanks for doing this interview. Is the simplified SG or regular SG machine with capacitor discharge as described in your book too powerful for small batteries like AA or AAA?
Yeah, probably. Maybe for short bursts. It might be, in general, yes. That's a pretty low, it's a pretty high impedance battery. In other words, it's not designed to produce a lot of currents, and most of them aren't rechargeable in the first place. If it's dead and you want to play around with, seeing if it can be recharged, then I think the straight simplified SG, where you're just taking the little spikes, zillions of little spikes, you might get a better result. But again, be very careful. And if it starts warming up, take it off. But in general, yeah, I would say it's too small.
Okay, from Coy Burton, has it ever been the case that the plates develop holes due to spikes too strong?
No, I've never seen that. Yeah. Never heard of that. These electrical spikes are not capable of punching holes in the chemistry that I know of.
Okay. From Robert Kramer, I have a 36-volt golf cart. What should be the maximum finishing voltage for this battery pack to prevent sulfation?
Okay.
Well, that's kind of covered with the 12-volt. If you just
basically, if you consider 15.3, topping for a 12-volt, then we're looking at around 46 for that 36-volt battery. Yeah.
From Coy Burton, and this actually comes up a lot. He's asking, can a battery be charged and discharged at the same time?
Actually, people try it all the time, and the efficiency is very low. And the reason for this is that there is only one electrochemical pathway in the lead-acid battery, and that is that you're either taking lead oxide and donating an oxygen to the electrolyte to form a water molecule. In other words, the oxygen from the lead oxide is combining with the hydrogen from the H2SO4 to produce a water molecule, and that's what produces electricity. And when you put electricity back in, then you break up the water molecule, and you want to do it in such a way that that oxygen recombines with the lead to form the positive plate, and then the hydrogens, instead of off-gassing as a gas, goes into solution as an H+1 ion, okay? So both of those things are the same thing in reverse. So one, they can't both happen at the same time. Many people think of, you know, a battery like a big jar of water where you can pour water in at the top, and then with a spigot you can pour water out of the bottom. And it works for water in a jug, but it does not work for a battery. So what happens is that the ions are just going like this. You're getting very, very bad efficiency of charge, and in general, almost no charge at all is going on if you're trying to use the battery and charge it at the same time. And this is why a lot of solar systems, at the end of the day, if you've been running the refrigerator or doing other things, taking power out of the batteries while you're trying to charge them, at the end of the day, the battery isn't completed charge, and then you run out of power at night. And this is typical, but the answer is no, you cannot charge and discharge the same battery at the same time.
Okay, now there's some questions specific to the SG or the SSG, the Bedini Schoolgirl Energizers. Now, although they can be used to rejuvenate batteries, any questions on actually running the SG and stuff, I would recommend going to EnergyScienceForum.com and posting your questions in there, because that is where John's official SG forum is. And anything, you know, besides what's in the books, at Bedini-SG.com, any kind of support and other things, and actually, you know, running your experiments with the SG are best discussed in that forum.
Yeah. Well, they're kind of beyond the scope of this interview at this point.
Okay, from Mike Ratty, I have a Shoemaker battery charger that has 125 amp, 225 amp settings. When I use that setting, the voltage on some batteries goes to 27 volts the first charge cycle, then slowly falls back with each charge. Is this okay?
Well, that's a pretty hot charger. I hope you're putting this on some pretty dang big batteries, first of all. The idea that the voltage rises so high is probably because you're trying to force the battery to take a whole lot more than it can, and it's telling you that its internal impedance is so high that it can't take the amount of current that's being offered, and that's why the voltage rises. As the battery heals itself and it starts becoming, the currents become more mobile and the ions become more mobile, on successive charges the voltage starts dropping, and what that's telling you is that the internal impedance of the battery is dropping also. So it is a good indicator that you're seeing that the battery voltage should drop under successive charges, because that means that it's probably taking more currents. But without a lot of other indicators, in other words, in that situation I would want to see not just a voltmeter, but I'd want to see a current meter on what's coming out of the charger. I'd want to see some temperature readings on the battery. I'd want to see a number of other things to determine whether or not this is actually a good indicator. But it could be a good indicator. But it's still, I think you're charging it too hot. It's a really big charger.
Okay, from Abdur Atbi, what consideration do you have to take when using radiant energy to rejuvenate large plates like ones found in big industrial batteries?
You're really, in that situation, you're throwing, what we'll say here is that if you're charging that battery with inductive collapses, okay, in other words, charging an inductor and then discharging the inductor into the battery so that it has an unlimited voltage potential, the big batteries are going to respond to this very well. We did a lot of experiments with this at John's in 2004 and 2005. But what happens is that the chemistry starts kind of acclimatizing to that method, and then if you try and go back and charge it with a standard charger, it doesn't work as well, and so you know, we stopped trying to do that. If you can get away with it once or twice to you know, break through some surface sulfation in old batteries and things like that, but in general we don't recommend it, especially for large industrial batteries like that. We don't recommend that as a continuous industrial charging method.
Okay, from Dana Moss, I have two 1000 amp 36 volt DC 18 cells forklift batteries. Yep. The voltage in one is 12 volts. How should I proceed? All 18 cells at once, or cut connection between cells and charge 6 cells at a time? Is there a way to get the voltage reading of a single 2-volt cell from an 18 cell battery without cutting all the links?
Yeah, you don't have to cut the links. You can in a forklift type of battery, typically there are external straps that just have plastic covers on them. So you can just pop any of those plastic covers off and just put a voltmeter in between you know, any two terminals, and yeah, you should be able to determine which cells are good and which cells are not. And the other thing to do, so yeah, if the 36 volt block is only showing 12 volts, that may demonstrate that you could have, you know, some big problems. And you know, that's an industrial battery with a lot of series cells, and so it's really, again, it's outside the scope of the general methodology for rejuvenating 12 volt batteries, which is what are the main thing we're talking about. These things can be worked on, and that's a $4,000 battery, so obviously it's worth rejuvenating if possible. It'd be worth working a couple weeks on it, you know, if you needed to, but you have to go about it systematically, and we haven't you know, ever published on the exact methodologies to do that. But I would definitely start looking at each cell, yes.
Mike Ratty, if a person wanted to build his own battery, what would the key points he would be trying to accomplish?
Okay. If you want to build your own battery, I highly recommend that you get a little pamphlet called The Boy Electrician. It was published back in the 1918 or 1920s.
It's old.
It's
Classic.
It's an absolute classic. It's fantastic. It has the complete directions on how to build a battery from scratch, and you know, you just buy lead sheet and you know, spacers and that kind of stuff. But yeah, there are directions for how to build a battery, a lead battery, and then how to form it, you know, from scratch on the internet. I'm sure you can find it.
Yeah, if you search in Google for The Boy Electrician, you're going to find the free PDF download all over the place.
Yeah.
So it's easy to find.
Yeah. It's a great book to have. Everybody should have that book in their library anyway.
Okay, from Steve Stucker, I have a bank of 10 12-volt deep cycle batteries to power aquaponics filter pump. Can you recommend a charge controller that allows me to split half the bank to charge and use the other half to drive the pump automatically?
No, because the charge controller isn't, most charge controllers aren't designed as battery swapping setups. I don't know of one on the market that will do it. So you can either do it manually, just you know, have a little bit of you know, a 2-minute a day ritual where you just do it yourself manually with big you know, knife switches or something. You know, or you know, figure it out with you know, timed automatic relays. But I don't know of anybody who's got one of those on Oregon.
Okay. Mike Goldman is asking how feasible is it to rejuvenate computer batteries? Again, we did cover charging lithium batteries and rejuvenating them. That was earlier in this interview, and so in the next 24 to 48 hours I'll be putting out a link where you can rewatch this interview on YouTube, and you'll be able to look over the parts where Peter discusses charging lithium batteries. Let's see. Jeremy Russ, which battery tools and methods would you recommend to do a business reviving old starter batteries for cars? Well,
That's exactly what the battery rejuvenation talk is about. I spent an hour and 40 minutes at the conference laying this thing all out. I think you'll find that just purchasing that product will give you way more than you thought you'd get.
And Jeremy also asks, if a deep cycle lead acid battery has been discharged and unused for many years, is there any chance of reviving it? We kind of covered that a little bit, but that's...
It's better if it had been charged and left, but yes, it is possible. But you have to understand the condition that it's in and adjust your rejuvenation processes accordingly. And again, that's all covered in the product.
Okay.
Great question, by the way.
Another question from James Gray. I also have a 15 kilowatt diesel generator to charge the Absolite batteries. More interested in how to restore the AGM batteries. They have removable caps and are in 3 by 2 volt units. I configured into 12 volt units. All the cells are above 2 volts. I plan to flood them with electrolyte, reverse charge them, and recharge them using a larger shop charger, convert them, and am I headed in the right direction?
Honestly, James, I don't know exactly what you're saying. If you would like, a private consultation, you could give me a call. I'm not offering that carte blanche to everybody, since I wouldn't be able to have breakfast for weeks probably. Yeah, you're jumping into a situation here which requires a set of knowledge and skills which you don't have, and and the equipment is expensive, large and expensive, and I think that you need to break these things down into smaller tasks again, and just you have. It sounds like you're good at grand vision and overview, and that's good. You need to know where you're going, but you need to first get these batteries operating. You need to charge them in a way that is not going to destroy them. Your 15 kilowatt diesel generator may be too big for these things. I don't know. Certainly one at a time it would be. And step by step by step, I see just a lot of issues that would need to be addressed. It's, you can write out this question easily, but I mean the answers are much more complex, and so, yeah, I'm sorry I can't be more help in this venue.
James, you can go to teslachargers.com, and the contact info is there on the banner.
Yeah. But we don't sell equipment that will allow you to do that in any simplified way. That's a very specialized set of issues for a very large battery system, and without understanding the condition that the batteries are in right now in their non-flooded state, and where they're going to end up after you put the electrolytes in them, and so on, without a lot of test equipment and a lot of understanding, there's just really way too many unknowns in this situation for me to advise you. Is really what it boils down to.
Okay, and we're coming to the end here.
Right.
Chris Farnworth is asking, what about if you need power from the battery but it's not charged? Could you attach the charger to the battery as a way to really get power from the charger?
No.
Like draw from it while the charger is...
No, that's not a good idea. First of all, our chargers do not function as power supplies. They function as battery chargers, and so most of them won't even turn on unless they recognize that they're connected to a battery. Most off-the-wall chargers, in other words, if you just go to an auto parts store and buy a battery charger, that can be used as a power supply. You can light light bulbs with it, you can do anything you want with it, but our chargers don't do that. Our chargers charge batteries only, they aren't power supplies. So using it that way, again, that gets into the problems of trying to charge and discharge at the same time, and regardless of how much you want to do it, the chemistry of the battery will not allow it to happen at any reasonable efficiency. So we recommend that you change what you want to do.
Okay, there's two final questions here from Abdur Atbi. When rejuvenating lead-acid batteries, one has to measure the battery capacity. Can you recommend a method or measurement tool that accurately and reliably measures battery bank capacity?
Well, you can buy battery capacity analyzers, but the expensive ones are based on a patent which throws a specific frequency at the battery and calculates what its internal impedance is, and so that actually doesn't measure it. That kind of gives you a calculated guess about what the capacity is. So the bottom line is, Abdur, there isn't any equipment on the market today that can actually tell you what the battery capacity is. If it isn't written on the label, or you can take the name of that battery and look it up on the internet. You may be able to find what the manufacturer rates the battery at, and but then the bottom line is the capacity is how long it will run a load, and that you're going to have to run an actual cycle on that. In other words, take power out of it. So if the manufacturer says it's a 200 amp hour battery and you put a 10 amp load on it and it stops in 2 hours, then for all intents and purposes it's currently a 20 amp hour battery instead of a 200 amp hour battery. So that'll tell you that 90% of the battery chemically is not available. So that's the only way I know how to do it.
Okay, from Dana Moss, if I hook a Variac charger to one cell of the forklift battery, will it charge just that cell?
Yes.
If I can do this, what would be the max charge voltage for a single cell?
The max charge voltage for a single cell for a 2 volt cell would be right around 3 or 3.1 volts. In other words, if the the galloping what we call galloping DC, or the peaks of that don't go above 3.1, then you should be okay. The real problem is getting diodes big enough to move currents of sufficient size, because that kind of battery is typically between 1,000 and 1,500 amp hours at 2 volts. So if you aren't giving it at least 50 amps continuous, it's going to take days to charge it. So yeah, the problem is finding big enough diodes. The next problem is going to be heat sinking those diodes so they don't melt. And then it would be better if you, instead of running a Variac at 3 volts, where 98% of the voltage is not there, because you'd be close to melting the few windings that you're taking the power off of on your Variac. So you're better off getting a big step-down transformer and running the Variac at higher voltages, and then taking the power out of some big winding on a step-down transformer.
Okay.
But yes, you're on the right track there.
Couple last questions
Sure.
came in. From Chris Farnworth, so a cheapo charger is equivalent to a DC power supply somewhere around 14 volts DC?
Pretty much.
Yeah.
That's pretty much it.
Okay, and Jeremy Russ, this is the final question here. Can I hook up multiple chargers to a bank of batteries that are linked together in series?
Yes, if the outputs of all of the chargers are isolated from the primaries, because I'm assuming you would be running all the chargers from the same power line, and if there was a common ground that went through the whole thing, the thing would blow up in your face, because you would be putting ground at various places up the battery bank. So you can do that only if the output transformers that are running the outputs of the battery chargers are isolated and independent, so that you aren't going to end up with a ground fault. So then you could do it.
Okay, so I guess we'll go, been about an hour and a half, we can go ahead and wrap up. For battery rejuvenation, I just let's see, let me send that link to everybody here. The link is batterysecrets.com. If you go there, batterysecrets.com is where Battery Secrets was at, but also Battery Rejuvenation is now on the same page as batterysecrets.com. And so if you already have Battery Secrets and you only need Battery Rejuvenation, you can get that by itself, or if you haven't, or if you've never had Battery Secrets and you want to get both, you can get both at a discount.
Yeah.
So both of those are available at batterysecrets.com right now.
Right. And there's a little bit of overlap. Obviously, in the first one, I talk about the chemistry and everything else, and I do review that at the beginning of Battery Rejuvenation. But there's a tremendous amount of information in both of them that don't, overlap. And I think both of them are really good to have.
Yeah, and I appreciate all these questions here, that we can get this recorded, because a lot of these same questions have come in over the years. And again, in the next 24 to 48 hours, I'll have this interview up on YouTube. And I'm also going to embed this on TeslaChargers.com, because it'll answer a lot of the questions.
So thank you so much for bringing up all the questions that we've been getting over and over the years. Right. And just really participating with us and getting a lot of other people to understand this, and I really appreciate it, really do.
Yeah, and of course Battery Secrets and Battery Rejuvenation goes into all this, and a lot of detail. You're going to see the PowerPoint slides on the screen. Peter will walk you through the chemistry, the charge-discharge charts, what that looks like, and he'll go into all the methods of the battery rejuvenation from scratch, taking a look at what kind of batteries to pick that's even worth your time dealing with. Some business considerations about the battery rejuvenation business, because with Peter and I working with Tesla Chargers, which we have been sharing John Bedini's battery chargers for quite a few years now, we have helped quite a few people around the world get started in their own battery rejuvenation businesses, where we have people that just get the 1AU universal charger, and all they're doing is charging people to rejuvenate tool batteries. And we have some people that are rejuvenating cell phone tower batteries with the big industrial chargers, and basically everything in between. Right. And the information that they're using to successfully rejuvenate those batteries and turn that into a viable business is the exact information you're going to see in the battery rejuvenation presentation. So again, thank you very much, everybody.
Thank you.
And we'll see you next time.
All right.
Okay. Information and content in both Battery Secrets and Battery Rejuvenation.
Exactly.
And that's going to, between both presentations, is pretty much going to answer just about everything that you need to know about rejuvenating batteries in the proper way. And I know, I do a lot of the customer service for Tesla chargers, and one of the most popular questions, even though it's on the website, is can these chargers or these methods be used for lithium batteries, or is it only for lead acids and NiCads, nickel metal hydrides? How do you answer the lithium question? Because usually the answer is no.
Well, we tell people on the website no, it's not for lithium. And the reason for that is that lithium is an explosive metal. When you just take lithium metal and you put it in water, it immediately dissociates the water into hydrogen and a hydroxide ion, creating lithium hydroxide and heat. And quite often that heat is enough to actually ignite the liberated hydrogen. And we've seen in the news over the last year, the fact that the Boeing Dreamliner 787 was grounded for 4 months because of problems of lithium batteries exploding into fire and causing fires on the airplanes. So lithium is a very interesting metal in the presence of water, and as we say in Battery Secrets, basically any battery is just a water fuel cell. It's a reversible chemical water fuel cell. And so when lithium batteries are charged, they're going to, there is a water cycle associated with them. And so these things have to be managed very, very carefully in lithium type batteries. Otherwise, they overheat or try and off-gas. And usually the lithium batteries are a sealed battery, so there's really no place for the hydrogen to go, no place for the heat to get out very much. And so typically what the manufacturers have done, especially with smaller lithium batteries, is that they put a fuse in line with the charger. And so because lithium and NiCad and nickel metal hydride and these types of batteries.
So together with Battery Secrets, and if somebody has never had or seen Battery Secrets, it is at batterysecrets.com. That was a presentation you gave about, I don't know, three years ago?
2010, or yeah, the 2011 conference.
Bedini conference out at the resort in Coeur d'Alene.
Right, exactly.
And so between Battery Secrets and with Battery Rejuvenation, those two pretty much make, that's the most comprehensive and definitive information on truly how to restore a battery, using the Bedini chargers, the SGs, or by whatever process to truly rejuvenate it, not by using additives and pouring different chemicals into the battery, but basically just using water and electricity.
Right.
And the proper tools and equipment to see what you're doing, you can, bring a high percentage of batteries back to life.
Yeah, if it's recoverable.
If it's not internally shorted or
Right.
not physically damaged or warped or whatever.
Correct. In other words, if it's possible to bring it back, then these methods will do it.
Right.
Right.
And there is a good percentage of batteries that a lot of other battery rejuvenation methods can't bring back, and chargers that aren't able to charge them up. And a lot of these batteries that are sitting in the dumps can actually be recovered to maybe 80% to even over 100% of the manufacturer's rating using these processes.
Exactly.
And then we've seen this over and over for years.
Right. Yeah, we've all of these things. None of this is theoretical. All
Right.
of these things have been done hundreds of times at Bedini's shop. And starting in 2004, when I was working for him, we started tracking charge and discharge cycles with computers and overlaying graphs and other things, and really starting to see what was going on in these processes. And so we really set out to understand the chemistry about what needed to happen, and so all of that is covered in these presentations.
Okay. Now together Peter and I run Tesla Chargers, which is part of our company, A&P Electronic Media, where we publish digital products. But at Tesla Chargers we get tons of questions that's very relevant to the information.
the insurance company will just say, well, you modified this and therefore your insurance doesn't cover it. So, and we don't want to be responsible for anything like that either, and that's the reason why, you know, we just say at your own risk, or just don't do it.
Right. Now for, you know, voltages, a lot of the questions that I get, that's, you know, very specific to charging batteries up to the proper voltages, or even draining a battery down. A lot of people really don't know what the difference is between a starter battery, which is like a, you know, a 12-volt battery in your car, at, you know, X amount, you know, couple hundred cold cranking amps or whatever, and then comparing it to the same 12-volt deep cycle battery, which is not rated in cold cranking amps, it's rated in amp hours.
Right.
And if you notice on your starter batteries, they're not rated in amp hours.
Right.
And so when treating a battery good, you only want to bring it down to its safe level. So you want to go into the discharge voltages for both a starter battery and a deep cycle battery,
sure.
12 volt for example.
Sure. Let's just go over the difference between a start battery and a you know, what we'll call a run battery, like what you'd see in a golf cart or something, or some other electric device that's just designed to run on the battery. Typically, a start battery has a lot of thin plates. In other words, what the chemistry and the physical makeup of the battery is designed to do is to provide you with 1,000 amps to run your starter motor for a couple of seconds, okay? And that's its main job that it has to do. So it has to have a lot of surface area, and it doesn't have to run very long to do that. So a start battery usually has a lot of thin plates in it, whereas a run battery has a lot fewer plates, but they're much thicker, because what you don't need as high currents, but you want those currents to be available for a long time. So that's the general difference in the construction of what's called a deep cycle battery or a start battery. But typically don't change voltage very much during the charge and discharge cycle. The voltage remains pretty much the same, but the total currents available are what's rising and falling. They're really designed to not be charged by pulses or anything that would look like a current surge or an over voltage condition. And many of the Tesla chargers have been designed to do that kind of thing, and because that works very well with lead-acid batteries. And so typically what we saw early on is that when you apply these methodologies to lithium batteries, it just blows the fuse in the battery, and then it refuses to do anything. So it looks like we started, you know, being told, you burned out my battery, and these are expensive, and it's your fault, and all that. So we just put everything on the website that just says, don't use these processes or our chargers on lithium batteries. Now, done carefully, there is nothing wrong with using a Tesla charger on a lithium battery. And the bigger the battery, the easier it is to do that, especially if you're using the 1AU, for instance, which has a voltage range that you can dial up. As long as you stay on the low end of the dial, you might get away with charging some lithium batteries. The problem is that if you blow the fuse, we can't, you know, help you with that, and so we don't want to be responsible for that, and we don't want to hurt your batteries. But that's really the issue. It's not that our chargers won't charge that chemistry; they charge it just fine. But there are these other issues, including heat, off-gassing, and fuses, internal fuses, which is why we say don't use our chargers on lithium.
So if you do use these chargers or these methods, or if you've built your own Bedini-SG, whether you're charging with the spikes or with the cap dump or whatever, completely at your own risk.
Right.
You know, some people have brought them back, but for the most part, you know, we don't recommend it. So,
and for these issues. And of course, if you go into the battery and you do a little bit of surgery on it and you bypass the fuse, you see, then if your house burns down, a year later, and they find this thing, in the fire.
this is Aaron, and with me today is Peter Lindemann. And today we're going to be discussing Peter's presentation at the recent Bedini-Lindemann conference that we had in Hayden, Idaho at the end of June. And Peter had two presentations at the conference. One of them that he did on Sunday, the last day of the conference, was Open System Thermodynamics, which is at opensystemthermodynamics.com. And but his first presentation that he did on Friday was actually Battery Rejuvenation, which is kind of a companion presentation to the popular Battery Secrets, which goes into the battery chemistry, how battery really works, what the sulfation process actually is when a battery gets sulfated, and that kind of stuff. And the Battery Rejuvenation presentation that you did actually goes into the methodology of actually nursing dead batteries back to life. So you want to kind of explain a little bit, a little synopsis of...
Yeah, the thing is that everybody's talking about, that batteries get sulfated and that you have to, get rid of the sulfation or something else. And so I really get more into exactly what the chemical state of the sulfation process is. Sulfation in a battery is not bad, but what happens is that if sulfate ions are left in the plates, they change form. So there's actually two chemical forms of the sulfation, and the first form is good. It's a natural process of how the battery is charged and discharged, but the second form is far less mobile, and that's the one that starts causing problems. So I get much deeper into the discussion of what's going on with the sulfate ions, and when they do change to the second form, this is when currents stop moving so well in the battery, and what we have to do to get that second form of sulfation back, to turn back into the first form so that it can be literally brought back into the electrochemical pathway. So that's really what it's about. This material has never been discussed in the public domain before. It's definitely not covered in Battery Secrets, which is just a general primer, really, overview of the chemistry of a battery. And so this presentation goes much deeper into exactly what's going on.